So today we are finally going to look at some proper integration. Now, yesterday you were looking at how to draw a family of the function, of the original function, if you were given the gradient function graph. So today we're going to be going from, if you had the actual gradient function, how would you find the original function? So let's just quickly go over differentiation. So if I had x cubed plus x squared plus 3x plus 2, if I was quickly going to differentiate that, so if f of, just put f of x in there, then I know that f dash x is going to equal 3x squared plus 2x plus 3, and the 2 falls away. So if I had this, if I had f dash x, and they said, what was the original function? And you couldn't see what f of x was over there. You'd say, well, whatever was up there was one more. Yep, so this 2 would have been a 3. And then I would have multiplied it forward. So actually that's quite handy. So that I know that would have just been that. This one, again, this would have been a 2. And I would have multiplied it forward to give me the 2 over there. So that's also fine. This 3 would have been a 3x. And then you need to remember as well that there could have been some constant added at the end there, and that would be a plus c. Now, to find out what that plus c is, you would need to know a point on the original curve, or you would need to know what the gradient was at a point so that you could substitute it in. Oh my gosh, that sun has just come out, which is lovely, but oh, I can't see a thing. It's right in the middle of my curtain. I'm going to move. Sorry. So, now that I can see, are you quite happy with that? Now, that's all very well, but what if it hadn't been a constant of 1 in the front? So imagine I had f of f dash x, sorry, f of x in the beginning. Let's start that again. F of x equals, what happens if it had been 2x cubed plus 4x squared? I won't go any further. Oh, do that. Plus 5x plus 2. So say we had that. Then if I differentiated, I'd have f dash x, and that is going to give me 6x squared plus 8x plus 5. Mrs. Smith, you are writing like a toad today. Okay, so then if I was given this and you didn't know this, and I was trying to find out what it was, I'd go, well, where would I start? So I want you to have a little think about this. Change my color. So, hope you've had a little think about that while I was changing my color. If I'm going to look at this over here, obviously this bit here is a big clue because I know it always went down 1 power. So this would have been x to the 3, and then I would have multiplied 3 forward and got 6. So it must have been a 2. And then this one over here, the x would have been a 2, and I would have multiplied 2 down, and I got an 8. So there must have been a 4 in there already. And this 5 would have just been a 5x. If there's a x to the 0, pretty much, which is 1, you just have to add the x in and then some plus c. Again, we'll look at later to find out what that c is, but for now, don't forget to put it in. So there we have that. And basically, what we come up with is there is a really, instead of having to do all that in your head all the time, to integrate, and I have got a value of anything really. If I had some ax to the power of n, it would always be, I'm adding 1 to my power, and I'm dividing A by whatever that power was, because I times it when I'm differentiating, I multiplied by it, so now I have to divide it. Let's just have a look at this. If I've got the 6x squared, basically I'm going x to the 2 plus 1, and I'm dividing 6 by 2 plus 1, which is 3. And that gives me 6 divided by 3 is 2, and x to the 2 plus 1 is 3. Let's check it with the next one. For this one over here, I'm saying x to the n plus, to the 1 plus 1, because there's a 1 over there, which gives me the 2. And then it's 8 divided by 1 plus 1, which is this power over here. And I get 8 divided by 2, which is 4. Okay, so this is how to integrate. So if I've got this, I integrate it to give me that. So hopefully that all makes sense. Let's just apply it with that now. So if I had f dash x equals 3x squared, that one's going to work, isn't it? Plus 4x, I'll make that 3x cubed plus 4x squared plus 2x plus 4. So we had that. I'm going to use this now. So this one here, it's going to be x to the 3 plus 1, and that's going to be over 3 plus 1, plus 4x to the 2 plus 1 over 2 plus 1, plus 2x to the 1 plus 1 divided by 1 plus 1. I'm doing my answer. And then plus 4x to the 0 plus 1 over 1. Hope you kind of get that one. It's like there's an x to the 0 there, because anything to the 0 is equal to 1. So this over here is going to be 3x cubed over 4 plus 4x to the 3 over 3 plus 2x squared over 2 plus 4x, and 2 divided by 2 just gives me 1. So you can have fractions, obviously, just like anything normal. Write them as a fraction. It'll kind of just give you an idea of where you've come from. So hopefully that all makes sense, and the work that you need to do is going to be on the OLE.